Hi, everybody. We'll wait a few minutes before we start. Good to see you all back for spring. If you are on Canvas, you can go ahead and check out the module for the week, and you can download the notes while we wait. Also check out the syllabus. Did you guys do anything fun over the break? I know some of you are in my online class. Okay. So let me get all the files open. We'll wait a couple more minutes for everybody to join, and then we'll go ahead and get started, okay? So if you just joined, go ahead and check out the modules in Canvas. Log into Canvas. You can download the notes if you like. We will go over some of the content starting with the syllabus first. So we're expecting about 40 something people in this class, at least close to 50. So sometimes if the traffic gets a little bottleneck, then I will turn off my video. But I will share screen with you still. So I had everyone on mute. In the case if you have questions you want to ask, just go ahead and unmute and ask, or you can type it in the chat. When I'm in screen sharing, sometimes if I don't see it right away, I will try to pause throughout and then I will address your chat questions, okay? But check out the Canvas module, download the notes. and then we will get started. Okay, so welcome to CIS-11. I'm glad to see that you made it. There might be some people trickling in. This is assembly programming, more of the advanced class that you normally would get with the programming under computer science, or if you're under math and science, you're required to take this. And the way I designed the course is I teach it with Lc3, which is taught at many different universities, including University of Pennsylvania, University of Texas, Georgetown, you name it, and also at Cal State San Bernardino. I know that some university will teach ARM, and we'll talk about how close it is to ARM and how you can take what you learn in this class and become an assembly programmer, or eventually work for, companies that produce chips like Intel, etc. As you probably have read, if you own iMacs and MacBooks, Apple has launched their first processor this year, and also they started selling their own system with their own processor instead of using Intel. And Apple uses ARM, and there are many different versions. Just think of it like, each one of the language would have its own syntax, kind of like how you learn Java and C++. So there are different instruction sets, but we are going to learn Lc3. It is the easiest language to learn in assembly, and it relates to other languages. So when you work with assembly, you will see that. So I will start with the syllabus, and I'm going to go into screen share. Like I mentioned before, if you have any questions, please unmute and ask, or you can type it in the chat and I will periodically check. Okay. So let's share screen real quick. So this is how I normally conduct the course. Is I release everything just like all the other faculty now on Canvas. So in the case that if you miss class session, you can still find the materials on Canvas. And at the end of each class, I will post the video. I made the page for it. And so you can watch the video, fast forward it to the section that you need, whatever you like. And I use YouTube because it's the fastest way for me to get things captioned. Usually when we get captioned anything above an hour, it takes days through a captioning company. So for this course, I will likely upload all the videos sometime later in the evening after Zoom has released it. So it takes a little bit to get it downloaded. Okay. So you will find your course information on Canvas. Some of you might have checked it out. So we'll start with the course information. This is the same content as what you find in your syllabus. And in this class, we basically would program in assembly. By the end of the class, you will be able to write a complete program. And every lab session, I walk you through on how to program it. I will not leave you in the dark. We will go line by line, and I will explain what it does. So that way you will be eventually writing loops, creating stacks, everything that you need to in a normal higher level program in a low level programming language. So this is a 3-unit course. It requires 54 hours lecture and 18 hours lab. I like to dedicate the second day in the week, which is Thursday, to work on our lab. We mainly have hands-on lab, in exception of the first week, because we have to cover some of the number system, making sure that you understand how to work with binary and hexadecimal, because this is what you're going to see in the simulator. At low level, that's what you're going to work with, is either binary numbers or hexadecimal number, and you will see that on the simulator. So by the end of the course, you will be able to analyze and interpret assembly language code. That means that you will be able to look at a program and know exactly what it's doing. Looking at from a hexadecimal format or a binary format. we will touch on how to bring a C++ program or even a C program down to the low level. So in the case when we're writing conditional or control statement, you will see how that's done in the low level. And we will use registers along with manipulating the numbers to really see the output. Even when we're dealing with text, right? Encoding using ASCII, etc. So you will see how a high level program will be interpreted on the lower level. And then you will be able to write and execute program in assembly language, and we are learning Lc3. So as I mentioned before, Lc3 is easy to grasp once you understand how it's structured, the syntax, how to work with registers. So in general, it's recommended that you have taken a programming class such as CIS-5 or CSC5. If you haven't, I recommend that you take it with this class so you can understand the programming concept and use it with this class and in your future classes. So the course information is listed there. It's also listed on the syllabus. You and all of the students that are joining in the session probably have seen this page. I don't use Confer Zoom only because I gave up my account and it took a long time for them to re-release it. So this is my own Zoom account and I have access to the cloud and I have extensive storage so that way I can have larger video and I will release video on YouTube as well. Then on the next page, you will find the syllabus. I embedded this so you can view it within the page or you can download it if you wish. And on the syllabus, it will look something like this. It has the information about the course as we touched on. This is a regular Meet online course and I do take attendance. So if you miss class, right, and you can still do the activity, there might be some point that you miss, but you can make it up by doing extra credit. And then if you complete the assignments, the wait for the attendance is not that much. I usually give student opportunity to do extra credit. So if you miss class, check out the extra credit assignments, okay? Like all the programming courses, you will need to spend a little bit of time outside of class, working on assignments project, taking quizzes, etc. And my quiz and exams are released via Canvas. And the assignments, you can submit that via Canvas as well. So the content of the course, we will start with numerical systems, looking at bits, bytes, words, and in assembly, we have to look at word size. Different assembly language uses different word size. The majority of the assembly language, since it's been used for a long time, it's pretty legacy. You would find that it's 16-bit per word. We'll touch on that later on in the next few weeks. You will need to work with registers and knowing where your data is stored. So we will see things at a low level compared to what you probably have used, compiler, interpreter in Python, compiler in C++ and Java. So we would actually experience the lower level of the actual program and we would use the simulator to be able to see that. We will talk about how control unit, the process with control unit, how it's fetching, decoding, and execution. And in a lot of the programming classes, they touch on this, but now you will be able to see the details. And this class, once you grasp the concept, it would all piece everything together. The other programming classes that you have, why processor does certain things, how is it allocating, or where is your data located. So we will look at memory addresses in hexadecimal and looking at how we can use numerical systems like binary to really see our data as we store it. When you create a variable in C++, what does it really look like at a lower level? So in this particular type of assembly language, Lc3, it doesn't use flags as often. There are some different component, but if you write assembly program like Microsoft ASM, or for Linux systems like NASM or even ARM, in those type of languages, you often see flags. And flags are just usually used for indication like negative values, or when it fills up a certain word size, etc. So we have to really visualize it at a conceptual level to really see, because all of this is just instructions that are handled by the processor. So we will take a look at how applications, what that would entail, like a full program, how that would be on the low level. So here is your learning outcome again, and advisory information. So it's recommended that you would have taken a class. It's not required. That would be in programming. So the book that I'm using is by the author, and they actually created this particular language for teaching purposes because it's closely related to other assembly language. This is often used for education purposes. And I will talk about using the simulator and where you can download it. So this book is free. And if you look, the content is a little older, but if you think about it, processor hasn't really changed too much. They redesigned it to be faster, right? To have more features, but the architecture wise, we have been using the same architecture for a very long time now. So we'll touch on the components of the processor, the elements on what is in charge of which functions. So you can find the link for the book download there. I recommend reading the book. It really pieced together the circuitry and talking about gates. And if you're taking physics, right, where certain physics class talk about how to deal with electrical components, looking at voltage, amp, etc. And when you go into computer engineering, a lot of these areas are going to be important. So understanding what is the architecture and how to work with certain architecture is going to be important for your career. So I put everything in modules, and each module will represent a unit starting with week 1. All the assignments, the videos, if I find tutorial resources, I will link it. So it's designed to really help you follow through each of the unit as you get through the course for 16 weeks. I do take late work. When it's about a week late, it's 10% deduction from your earned grade. 2 weeks late, that's going to be 20% deduction from the earned grade. I do take it in the 3rd week, but after the 3rd week, I usually don't take it because I don't want somebody to turn in a lot of work at the end. It's unfair for the other students that's been doing the work all along. So it's important that we follow the deadlines and be able to submit it. And if you need help, please reach out to me. I'm usually pretty good with email. In the case where if I don't respond right away, I will try to respond within a day. And if you need help, please stop by and see me during office hours or make an appointment to see me. I will take time to help you. Okay. There are some in-class assignments starting with today. I usually walk the students through the assignments. I will do the activities with you, also with the lab as well. So before I would require it at the end of the session, but I understand, right, that sometimes, it's hard to grasp the concept right away. We wanted to spend a little bit more time going through our assignments again. So usually it's due 2 days after. It's assigned for the in-class assignment and for the lab. Quizzes, exams, and other things will have its due date. Usually quiz is due at the end of the week. So you have the whole week to attempt the quiz. And for a course project, you will have a course project in this class. And I tried out using Team in the course project for assembly, and it really helped the student working with each other, understanding each other's idea to be able to build a program together. And many of you are going to become developers and engineers, so it's important to understand how to work with other developers and other engineers. So we wanted to maybe think about who you wanted to team up with. And that's what the discussion thread for this week is really for: your goals and objectives in the course, and possibly looking at people that would be in your team. And I will release the project a little sooner. When I read the survey from my online class for the 6 weeks, I released it halfway through because I just didn't want to overwhelm the students. But tremendously, all the students came back and said that I should release the project sooner. So I will release the project sooner, so you can start thinking about what option you wanted to do, and how you're going to coordinate time to work with your team. Okay, so the project is going to be due at the end of the semester. So that way you should have ample amount of time, at least a month and a half or more, to work on it. So I will not take late course project. Okay. I don't give midterm. Course project is like another form of final. So you will get periodic quizzes, like every few weeks you will have a quiz. And I will use some homework assignment to help you prepare for the quiz. And I found that through my 15 years of teaching, it really helped the students. And I've taught from programming to cybersecurity to project management. You probably read some of this throughout some of the profile and discussion posts. But it's the review assignments are mainly helping you preparing for the tests and quizzes. So here we are with the grading. Homework assignments will be a few throughout the semester. I normally, the way I design my course is each week you will probably have like 2-3 items to do, at the most 4. But I feel that, that would give you time to spend a little bit more time on the assignments instead of giving you a lot of things to do. So homework assignments, like I mentioned, those are usually review assignments, and that kind of cover all the weeks that we had for that particular quiz. And that's 15% of your grade. Your quiz is going to be 10% of your grade. In-class assignments and participation is 20% of your grade. Lab activities, we will have lab every week. For most part, that will be 20%. And then your project is 15% of your grade, and exam is 20% of your grade. Now, for the students that decided not to turn in their project because maybe they ran out of time or whatever it is, right? They would just receive the non-credit, the 0 for that part. And so if a student going into the final and the course project with an A, just have an expectation that it will lower your grade, right? I'll try to do what I can with extra credit, but I cannot give a lot of extra credit because that's what it's for. It's just extra credit, just maybe a few percentage that's going to boost your grade. That might help if you are at the cusp between an A and a B, or a B and a C, things like that. So don't rely fully on extra credit just to boost your grade tremendously, but at the same time there are opportunities for you to get some missing points. Okay, any questions so far? Please, if you have questions, unmute and ask. Overall, for the code of conduct, there is student grievance policy in the catalog, and there's a form through student services in the case where there's complaint or any kind of issues that you have. You can submit that. That goes to the chair and the dean. And then we would follow the student conduct standards based on the college policy. I do have requirements with attendance since this is a regular meet course. I feel that if a student miss more than 2 weeks and not do anything in the class, not participating, that student has missed a lot, because this class is a little bit more of an advanced class. So you will try to be able to grasp the concept as much as you can. It's going to help you prepare for the upper division class in the university level, because when you take algorithm, they're going to expect you to know all of these concepts already. So I reserve the right to drop a student if they don't attend or submit assignments in 2 consecutive weeks. If the student decided to drop the course, make sure to look at the deadline on WebAdvisor to avoid a W, or, and if the student doesn't drop my class and not submit anything after the deadline, that student will get the grade that's received in the course. I don't like for that to happen. I usually reach out to the students, but in some cases, right, if I don't get any responses after continuous tries, then the grade earned is what that student's going to receive. Behavior issues, just try to be respectful to each other. We're going to avoid, major conflict. If you have problems, please address it with me, and then I will address it, especially with another student, if that's the case. Make sure that we're sensitive to feelings, and if any form of disruption in the class, I reserve the right to dismiss the student from the section, and also carry through with counseling from the student services. Now, I know that there are tons of other programs out there on GitHub and different websites, right? But you want to do your own work. I do check using tools, and I do read the code. I spend a lot of time grading course project because I give thorough feedback, and I also check out, how you write your program, what kind of ideas you have, how your approach is going to be. So do not copy and paste code and submit it. I can tell. So please make sure that you do your own work. Now, when you're working in team, right, we will have different team allocation and how the work is going to be distributed. And then your team evaluation will be carried into your grade. So any student that's caught cheating, I had caught one student in my, not winter, but the prior semester, the fall, on their course project. And unfortunately, it drastically impacted their grades. I decided not to drop the student at the end, but they just didn't receive a good grade at the end. So I don't want that to happen to anyone. And at university level, they take this seriously. The student would actually get dismissed from the school. So make sure that we do our own work. With accessibility, if you need special accommodation, make sure that you contact the SPS department, fill out the form, and then they will forward the accommodation request to me. Things like extended test time, if you need any special accommodation, make sure that you reach out to them. That's would be the process, and then they will communicate with me and I will set that up. For my office hours and my email, I would respond back within 24 hours, if not right away. And you can also see me during my office hours. And if you call this number, it will just go to my voicemail, as I'm not on campus right now. So the best way to reach me is email. And then my office hours are listed here. I know that it might not fit for your class because some of you might be working, and you might have time in the evening to attend class. But if you like to schedule an appointment, we can work out an appointment and we can talk about, what you need help with or any questions or concern that you have. And the access information is listed there. It's also on Canvas. Okay. Any question with syllabus? No question. Okay.
Oh, for the project,
Yes.
could you kind of explain a little bit about it?
So the project is going to entail various options like you would work with your team and select an option to be able to write a complete program. It would have some form of input and output. It would, and that in assembly requires a little bit, just a huge section. So, and then it would, so one of the example that I would give you is do a grade calculator, right? To calculate the average grade and determine the maximum grade for a student, and then convert that grade to a letter grade like A, B, C, D. For C++, Java, Python, that's super easy to do. You can do it in a few lines, right? However, in assembly, it's different because we have to utilize registers and to convert our text into ASCII values and then, treat it as a number. So I will walk you through the lab, and then once you complete most of the lab, you're going to be able to address the project easy. I will give you criteria in the project, like these are the things that you have to meet, and if you meet the criteria, you get a good grade on your project. So you would have various options to do. That's one of the options. The other option is to do an easy encryption program. And I will talk more about the project in a future weeks. When I release it, I will actually cover it in your class. Okay. Any other questions? Okay, no other questions? All right. Let me see, there's some chat question. Okay. All right, textbook information is there. And then my contact information is there. So you have access to Canvas, you can see it. There are resources at different campuses. So if you ever need like a laptop to loan because your computer is not working, make sure that you utilize the resources. I also include Lc3 resources. And if you wanted to have a head start on this, you can visit this link, Lc3 Simulator. You can download it. And it's a very small file that's going to be downloaded. This one work with Windows. There is a Unix version. Now, I know some of you use Mac OS. That's fine. You will need to use an online emulator for that. Okay. So there is also links that you can find, right? And so there's tutorial videos. So here is the Windows one for the simulator. And then I had dropped in some of the link for the resources for the online one. And so here's the online simulator. And you would need to use that if you're using a MacBook. Okay. Now, when you watch this tutorial video, it might be confusing at first. So maybe in a couple of weeks, it's all going to make sense, because I'm going to walk you through how to make a very simple program, like just adding two numbers together and get a sum. And then we will go through like how to put in text, how to output text, and so forth. So we will do the IO part so you can see. Okay. Okay. Now, there's some resources for OS programming, and you can take a look at how things can be written for NASM. So anytime you see ASM, that's assembly, okay? An exception for the more modern assembly, they use like ARM or AVR, and I will touch on that next. So to work with kernel, to write OSs, to even create compiler, you can program from assembly, or even for my security interested students, right? I talk about this in the last few semesters when I taught this. I said, if you understand how to write a program in any language, from assembly to higher language, right? You can even think about how, someone would write a worm or a virus, because ultimately it is a program, something that would just continuously requesting for services from a certain server and flood it, right? Launch a denial of service through an automated program, and then be able to, replicate it throughout with bots, things like that. So if you understand how to write a program, right, how to write some of the instruction for the program, then it should be easy for whatever purpose that you are trying to achieve.
Are you
So
talking about like DDoSing? Like,
yes,
oh,
even DOS and DDoS, right? So in the case where if you're looking at something like ping, right, Smurf attack, you can ping someone thousands of times and then just make their system so busy to make it unavailable. Yeah, and that's simply just do what? Request a service through ICMP, right? Keep pinging someone and you can have it count, right? You can do it 50,000 times, etc. And in command line, we already see that. And command line is an application, right? So, you know, some of this kind of bringing back to how software works with hardware, and we really gonna talk about how the architecture really handles a lot of the commands and the instructions at the low level in this class. Okay. So, sorry, I love security. So for course plan, we have the units broken down here. You have a spring break in the middle of April. So I will try to, you know, not do too much there so you can have a little bit of time off, relax, enjoy yourself. As we are getting vaccinated now, right, we'll be able to do a little bit more things. But your final exam is going to be the second week of June. So for your class, final is going to be closed at 11:59 on June 10th. And then your course project is also due that week. You can turn it in early, that's fine. The final is going to open at the beginning of the week and it's going to close during that day, at the end of that day. So, you know, make sure that you coordinate your schedule. If you have work, things like that, make sure that you take time to take the exam, okay, and submit your project.
hey, professor, for the project,
Mhm.
if we turn it in early, do you like give like what's it called? Like pointers and tips on how to get more points on it?
What
Or
what I did before for the students is they had sent me their draft, right? Like they sent me the ASM file. I simulate it, I run it, and I look at it, and then they had sent me their pseudocode or their flow chart. And then I look at it and I can point out some of the things that they need to improve on. And the team that did that, they drastically improved, right? Instead of just turning in something that sort of work or something that's not very, you know, efficient, right? But at yeah, I'm willing to take a look at it if you like, right? Just drop me an email or see me during office hours. Preferably, if you send a file, I can take a look at it and I can tell you. I had a student that turned in 1,010 lines for a calculator. He did a full calculator, you know, not fully scientific, but you know, with all the buttons, not the buttons, but all the feature that you would see with the buttons, right? Like, you know, handling power, etc. So anything that you can do in C++, Java, Python, you can do it here, but it just takes a little bit longer, more code to do it. Yes, I will look at your program that you created and I can give you feedback. But if you do turn it in, I don't grade the project until everybody submitted because Canvas gives me a link and then I just use the link to grade it. And then I give feedback, and sometimes I would give feedback as a group if you are doing group work. Okay, any additional questions, you can put it in this discussion thread. I periodically check it. Some students actually create their own thread, that's fine. But if you need immediate attention, please email me. I will address it right away or see me, okay, in Zoom. Okay, so anything besides course, navigation, syllabus, any concern? All right. Okay, so no other things. Okay, so this is the page. Basically, it tells you the tasks for the week. And it also have some of the notes. This I originally used this to distribute notes, but sometimes students don't see it, so I created a page and added the notes. There's some PowerPoint from the publisher. Sometimes I use it, sometimes I don't, but it's there for you in case you need to reference it, right? When you read the book, there's some explanation that's added into the PowerPoint, that the authors actually, they created the PowerPoint. So I wanted to share that with you. And then I supplemented some of the notes to make it a little bit more modern and understandable from our perspective compared to years ago when they wrote the book. And this book is still being used in, like I said, many schools. So, and then for this week, there are tutorial videos. So if you have taken my CIS-7 or currently in the class, you're going to see similar videos because we start at the same spot. I wanted to make sure you know how to use binary and hexadecimal. I know that some of you have taken CIS-7 with another faculty before, but I wanted to make sure that we meet the baseline of knowledge. And then so that way you're not lost when you're looking at, you know, your simulator. So we will start with number system, and then we would work our way through the assignments and the lab this week with number system, and the notes that you find is here. So what I will start with the lecture officially for this week is, let's talk about assembly language first. Okay. So give me 1 second. And you will find that also to download. And if you need Office 365, I will put another page on there. But when you use Canvas login, it takes you through the CAL portion of it. But if you need to download it for your system, right, they give you free license for Office 365. I'll post that. Okay, so I briefly mentioned this, but assembly, ASM, is the language. It is really at the lower level. So if you write like a statement like C in, right, or C out, or when you include a certain library, all of that is really already handled with the compiler after you compile the program. Or in the case of Python, you use an interpreter. Now, we have to really work with the instructions and what would be the storage inside the processor. So you are working directly with the processor at this point, right? What is the processor seeing? What kind of instruction is it using? So the programs that's written in assembly language are compiled by the assembler, and every assembler has its own assembly language. So that means that every chip, right, there would be, sometime manufacturer would make a series of chip that would use, you know, specific assembler. In the case where if you're looking at Apple or you know, or even the Arduino, if you're familiar with the Arduino, the microcontroller, right? So for, in our case, we use Lc3, but if you're looking at the Apple chip, it would have its own assembler, right? It understands a different set of instructions, very much like how, you know, someone is from another part of the world and they would understand a certain type of language, very similar to that. So now it is a little harder for the human to really read the programs. It's very close to mathematic. It is mathematic manipulation compared to what you see in C++, Java, Python, JavaScript, etc. That will be higher level language. The disadvantage of this is that it would be explicitly used for that particular chip. So Intel, like the x86 for 32-bit, it uses a certain set of instructions, and also their models use a certain assembler. So that means that it's going to be tied to that particular processor or that group of processors and cannot be used outside of that. So it's not as versatile as what you would see with, you know, something that would be at the higher level. But the advantage of this is that you would have complete control, because at this point on the lower level, you can handle IO, right? Even a mouse click, right? A keyboard type, all of that, right? because ultimately they are all signal that's being interpreted by the processor. Okay, so with this, what we see is that when we write something in higher language, in a higher level language, it's going to be translated to the lower level, and basically the assembler is going to handle as it compiled that program, right? So you would have more, there's more accessibility with that on what we can do with that program at the lower level. Okay. Then you do have some mid-level languages, provide some of the in-between from the higher level to the lower level. And that would be used for to write operating system like Windows OS, etc. Now here, I added some more links compared to your note, but I wanted to see. So when we were talking about architecture, there's certain architecture, right? So if you're into cars, right? I know many of my students are into cars because I see their program being submitted for their final project. Something like, well, you know, import cars are different than domestic cars, like, you know, American made cars. You know, Hondas are different than Nissans, or Fords is different than Camaro, right? But ultimately it's categorized in a higher level where we would have a certain category that would be this type of architecture compared to another type of architecture. So there's an umbrella of a type of processors, and then within that you would have subcategory of it. So for ARM, you know, there are jobs now currently all the time. I see it posted for ARM developer, and previously, this was named as Advanced RISC Machine, or originally Acorn RISC Machine. And this is a family of RISC, okay? And RISC stands for Reduced Instruction Set of Computing. And so the processor is configured for a certain environment. So if you wanted to check out things about, I put Wikipedia in here, but it gives you a good chart to really look at. Let me see if I can open it up here, and show you to look at the different types. Okay, so here's the processor, right? And then, you know, it gives you the description of it and the different types as what you would see here, like different version when it was released, support, right? And a lot of the documentation that would go into this. So if you wanted to practice ARM, you know, you can use a Raspberry Pi, and then you can also use a simulator with the Raspberry Pi to be able to write that. I know Microsoft releases the IoT Hub, and they, you know, I've been trying to get the school to get us resources for cloud use so you can actually emulate the programs for language like ARM, but there are free ones available. So if you wanted to practice, you can take a look, and then, you know, read up on how instructions are used, what kind of registers it use. I think some of them use 12 or 14 registers, compared to ours is only going to use 8. Okay. So here it talks a little bit about that. So you can see there. And then, you know, if you're looking at smartphones, sorry, let me do control click here. If you're looking at smartphones, a lot of the smartphones, like your iPhone, uses ARM. Okay. So here it talks about how the type, so like the Cortex A78, and you would know that, you should know that, you know, Apple uses ARM, but there are other companies that produce like processor for Android phones that also use ARM as well. So there are different generations and different types. That's what you would see. Okay. Okay. And then, so there are about 160 billion ARM chips produced. vary a lot since 2019, and it's more now. And most of the ARM is widely used instruction set architecture, your ISA, which we will touch on in this class. And ISA produce the largest quantity, so they're able to produce ISA architecture for even the modern chip that what you see today. And then if you're looking at the Arduino, when you program it, right, it is in C, but in assembly level, it's called AVR. And NetWide Assembler, this is often used for web browser. I know that there are some companies that hire developer to write assembly language for search engine, browser, etc. And also, you would see other higher level language as well. But NASM uses it. You can have it 16-bit, 34-bit, and 64-bit programs, and it's considered to be the most popular for Linux systems. So, when you write applications, you gotta look at the compatibility, not only with the operating system, but have to deal with hardware as well. And that's important. And this is why what you see is Mac OS, transitioning from Intel to their own chip, right? There are processes behind it because instruction sets are different because the chips is designed to understand different instructions. So, okay. And then Microsoft ASM, or known as MASM, for 32 and 64-bit. So they scale it out for 64-bit now for the Windows OS. Okay. So any question with assembly? So this kind of give you an overall brief overview about assembly language, different types. Okay. No question. So when we look at the processor and how conceptually it's understanding all of this, right? We would see that it would look something like this. So let me zoom in real quick. Okay. So there are different, and we will come back to this. There are different units, and this has been conceived since the 40s, right? Von Neumann, he thought about how using, of course, ideas that was generated by other scientists as well, but he thought about how different units would have different functionality. And from inside the processor, we would see that we would have to ultimately use arithmetic manipulation. And this is what you're going to be doing in this class, is to look at arithmetic on how the processor handle, your code at the arithmetic level. Okay. So the arithmetic and logic unit, it would take that and it would, so even when we create a variable in C++ or Java or whatever, right? All of that will be broken down eventually down to 0 and 1s to the machine language, right? But at the assembler level, we would have to see which register stores it, right? How is it manipulated to, identify the address where that variable is going to be, okay? And then we would have shift, complementer, and status flag. And the flag just tells it whether it's full, it would have like some kind of sign, etc. So for the operation behind it. And then the register is where our storage is going to be. And think of this as like a temporary location, right? What we can do is we can move it in and out. So when you deal with numbers, right? Like if I do a 1 + 1, what I simply would do is I would take one register, very much like a variable that's going to hold 1, and then another register that's going to hold the second one, and I would add it, right? And take the sum and put it into the third register, very much like what we do in C++, Java, other languages. One variable hold a value, another variable hold a value, right? We add them together and we store the output into a third variable. So you would use 3 register, and those are just going to be the location, or they refer to as files, right? But it is a location where you can store your data temporarily and use it. And then at the end, right, we can actually see the output in the third register, or what we would see in C++, the third variable. So what you would do with this is you would use it, and in Lc3 you only have 7 starting with 0, and some register you can use it for, you know, specific purpose, right? Like to be able to initiate for output on screen to display, you have to use a certain register, and so forth. So now the bus is just the channel where all of, you know, the communication happens, because we have to take what's here, be able to transfer it, bring it over here, so that way we can do the calculation, right? And the control unit is in charge of the operation. So what you would end up with is that we need a storage, right? And we need some way to calculate, and we need something to coordinate the process. So, and your computer, ultimately it is a calculator, okay? And it only adds. So when we work with the lab this week with the complements, you will see. So the architecture that we're learning is ISA. Make sure we remember this piece of, you know, lecture right now, some of the question you would see on the quiz and also your final exam, okay? So ISA, instruction set architecture, and for this, what we wanted to, so this type of architecture, right, it's a common classification for the architecture complexity. How complex is it? Some are more complex than the other, okay? So with the complex instruction set computer, right, that's a category for it. It would be specialized using a certain instructions, and it's rarely used for your practical program. So now if you see, okay, so if you ever shop for processor, right, like to build your computer or to upgrade your computer, right, you notice that they advertise about cache, right, the size of your cache. Why is that used? Why is it important? Why would I care about a good size cache? Anyone know? So this is going to be used for what? Temporary storage, right? So instead of, I see some chat answer. Fast storage, that's correct. Okay. And as we advance in computing, you see now in the market cache size is drastically higher, right? And so this is just temporary storage, and we wanted to make it's a fast way to store something, okay? So whatever that's stored from the main memory, it can also transfer to the cache. That would be transfer back and forth with the instruction for the data path and the control unit, and how that would be broken down into calculation at the end in 0 and 1s. Okay, so that kind of give you a picture visualization on how that is. So for CIS, okay, directly uses memory instead of register file. RISC is what we're learning. Lc3 is RISC, reduce instruction set. Okay. Now for the CIS, which is more complex, it would use the memory instead of the register inside the processor. And this architecture uses cache memory, and it holds data for the instructions. So that's where it's going to store your data, is going to go into cache, compared to the RISC reduce instruction set. It works with registers. Okay. Now, the RISC instructions that could be ranged in different sizes, and the clock cycle required to execute that. So for the CISC, they are executed in the microprogram with the micro instructions. And in this class, we're using RISC, the risk reduced instruction set, instead of CIS. So something like this. If we're doing a 1 + 1, right? Like I mentioned before, we would take 2 registers, store the 1, the other 1, and then we would add it. Now, for the MBR, that's gonna, the result, it's gonna put it into a third register, and after the 2 register is used, it's gonna flush it, right? It's gonna clear it out. So once it moves through the register to add, nothing is there. Unlike your variable in C++, Java, other languages, you would have it there, right? And so now, after your program is finished and ran and compiled, what that would do is it gives that variable space back, right? But for the processor, what it does is it's just going to move that number in, use it, move it out, and get rid of it. It's blank again. So when you work with register, think about how it's not going to be permanent. Nothing is going to be there, because if you go back and look at it, it might not have the same value again, right? It's going to be different because it's already empty. So it's going to be very temporal. That's what I'm trying to tell you. And so to execute the step, what it's going to do is going to use the control unit, right? Once it calculates the arithmetic and store it, right? It communicates through the bus, and it's going to say, okay, it's done now. That's gone. Next step. Okay. So there's some advantages for the Cis architecture. Okay. In the design with the control for the wiring, their instruction set, the purpose on how to carry out command as is stated there, and how it's not, so when the compiler needs to be very complicated, the microprogram handle the instruction sets. So it has a built-in microprogram. The disadvantage of CISC is that it is older and it requires subsets instruction that's built into the actual chip hardware. Okay. It's also going to be slower, so you can't expect it to be very fast compared to RISC, which is still being used today with ARM, right? So the complex hardware, it's harder to build because, and there would be more required instructions for the microprogram within it. So examples for your CIS processor, the older Intel, some of the IBM ones, some VAX, Motorola also have processors that would fall under CIS. Okay. So for us, we are going to learn reduced instruction set computer, which is RISC. Okay. And it is reduced for the usage of, it doesn't require much of the memory for the compiler. It requires more complex hardware. So if you have less instructions, you would have more complex hardware compared to more complex hardware would have less instruction, and then they would write the microprogram instructions. So you would need to use a separate instruction for data and caches, and that would be 1 instruction per machine cycle. Okay. So with this is that here, they would implement the instruction with the data here. So the instruction is going to cache on its own section, and then the control unit's going to be able to utilize that. Okay. Okay, so as you know, right, when you compile your program, it has to fetch, decode, and execute. So what does it mean? It has to take what that program is, right, break it down, translate it, right, and then be able to execute it. And so when we do this, it has to be done in stages in assembly. We have to take the instruction, right, tell it that go find it, and then once it gets it, it's gonna translate it. Once it translates it, it's then gonna execute it. So there are processes within that. And so when you're working with the compiler, this is what's happening in the background. You have different instructions that would be in different stages just for that program to run. Okay. Any question?
By instruction, you mean like the code or like number system that we're
So
putting in, right?
yeah, so your code in C++ needs to be broken down to the low level instructions, things like add, right? So in the case where if you're doing like an if, you're gonna have to jump because ultimately it's branching, right? So if you're doing an if in Python or C++, you would say if a is equal to 0, right? Do this, okay? Or, right, if else, right, do another thing. So what happens is what first you're going to have to tell it that this is the equal to the value, right? Check it for 0. If it's not 0, right, then go to else. So it's actually moving to the next part. Okay. So you will see. So at the assembly level, there's different instructions that we use. And for Lc3, we use arithmetic instructions. And most assembly language, you just use arithmetic. Microsoft has additional instructions like jump and jump to different label where you can move to different part of the program. But that's just because their architecture is built with additional instruction sets. It's able to understand different, think of it like different type of commands for that processor. Okay. So some like an example that will be like this. Load A, load B, right? We're going to bring it to the register and then add it. Okay. So any other questions? Okay. So what would be considered under RISC? Okay. You have AVR, that's Arduino, ARM, Raspberry Pi, your processor for iPhone, Android. Okay. And then you have additional for could be industrial use. And sometimes you would have microcontroller for industrial use for farming, etc. Those would probably classify under RISC. Okay. And even communication system. Okay. So I want to focus on advantages and disadvantages. Here are the advantages and disadvantages. You will find questions on your quiz and final related to this, the comparison between the two. We touch on how the performance is better with RISC, faster. Okay. You would have less reduced instruction set, hence the name. That would make it where you would have more memory management capability. And with the reduced by the architecture with the smaller chip, which consists of components that will be more single. So, it can be designed faster. So you would see that's why we saw on Wikipedia that they said 160 billion approximately since 2019 compared to CIS, which, you cannot have as much quantity because it would require more to produce. So, however, right, RISC processor require very fast memory to feed the various instruction. So that means that the larger cache is required in most RISC. Okay, cache size needs to be bigger. Okay, so when you see cache size now, when you're shopping for processor, that just means that you have space more to handle instructions. Okay, so this gives you the table. Take a look at the table. Some of the question you will see also on the quiz and exam. Okay. Anything on the content for this? Okay. Lastly, before we go into binary and hexadecimal. So machine language is built up from discrete statements and instructions, okay? And we would use registers for arithmetic, addresses, and control functions. Now, memory location often would be referred to as offsets. And when you're looking at memory addresses in your simulator, it's in hex, okay? And in Lc3, we started with an X. A lot of the assembly language, when you see the X, that is the location in memory. So we can say that we would start at this part of the memory, hex 3000, and then we would be able to go from there. And so from there on, it's gonna be able to set up, right, your data in the address that will be subsequent to that, okay, depending on the size, the word size, and the size of data that you put, okay. Kind of like how you use type variable, and that will be at a location. If you use long, right, that will be in a different location that will be larger to hold your data. Now, we can say that copy of the data from a memory location register, that would, sometime we can copy that or we can duplicate that data. And in most cases, when you're working with pointers and things at the higher level, all you're doing is point to that location. It doesn't really make a copy, right? But in the case where if we make a copy, it's going to take that data and it's going to put it into a subsequent location with the same type of data. So we can do copy from one register to another register, right? Like let's say I put a 6 in one register, and then I can take that and I can copy it to another register. So both of the register now have the 6, right? And so maybe I can divide it, or I wanted to use it to add, or whatever it is, or I can use that 6 to do a loop count 6 times. So what I would do is I would need to point it to the register, and once it's used, it's going to move it out and then store your data in the MBR. Okay. So now, basically all we're going to be doing all semester long is this: add, subtract, multiply, and divide. Okay. And you will write it in assembly. And that's all it is. So it's really easy once you see it, right, mathematically on how you wanted to move it. And so that way we would use the register to store things, add things, divide things. And so when we multiply, that just mean add, right? When we subtract, add the negative. So very easy to do. Okay. All right. So that kind of highlights some of the things about ISAs, how we can increment, decrement, save the operand, and we'll touch on what operand is. And we can also use code block. And in Lc3, you don't have a label format. You would just move through the register, but other languages, you can create a label. C++ does that too in C. You can jump to a different label, and Python does it. Okay, so, all right. So I encourage you to look through the content of this, read a little bit more on it to identify the difference between complex instructions and reduced instruction sets, on how it's using memory and how it transfer, right, the data across and be able to process. Okay, any question? Okay, so next we're gonna work with numbers. I wanna make sure you know how. So for your assignments, we are gonna do the in-class assignment for most part. I'm gonna go all the way till about 8. And don't forget to post discussion. I saw some of you started posting discussion already, right? So that way we can set up our team. So for our assignments, you can refer to the binary hexadecimal notes. I added that because that way you can have a point of reference in the case where you haven't worked with it before. So unit 1 notes. So the numbers that you've learned since you were a toddler is a decimal base number, 10 base, okay? And that's what we use for our math. That's what we use to count. That's what we use to be able to determine, analyze, function in this world, okay? And so here it talks about the base 10 numbers. When you work with base 10, you need to convert it to what the machine can understand. You have to talk to the computer and tell it this is the binary, right? This is the hex value, because your simulator, your processor will only understand, right, hex and binary. So ultimately it breaks it down to 0 and 1s, which is in binary. So what we need to do is we need to know how to convert things to binary and hex. And even in the decimal system, we go from right to left, because when you're looking at the digits, right? Like if I'm saying 4,532, the single digits start here. I'm sorry, this should be 2. I don't know why I typed in 1 there. And so 2 times 10 to the 0, that means 2 times 1, that's a 2, right? And we say 30, so 3 times 10 to the first. So as you move left, you see that it's larger, right? In scale, that's going to be a 10 scale. We multiply it by a 10. And then the next one, we multiply it by another 10. And then the next one, we multiply it by another 10. So it's the 10 to the power of n.
Wait,
So,
should that one be 2? The one that on your right? In the boxes.
Yeah, you're right. I should type that again. Thank you. Okay, let me resave that. I must have been sleepy when I uploaded that. I'm sorry. So the least significant is on the right, right? And as you move left, you would see that it's higher, right? And we call that most significant. And the way that human designed the computer is we mimic its thinking or its computing power to how we think, okay? So to be able to implement this, so if we count it this way, how can we create something that would be able to mimic that, but in a larger scale? So what happens is that they implemented what would be the binary system, and the bit is the smallest unit of data, right? The smallest unit of information, that's what you would see. And so
Wait, did she just disconnect?
Yeah, I think so.
Yeah, it said she left the.
We'll just wait.
sorry, I got disconnected. Okay, let's go back. Okay, so when we were touching on this, so bit is the smallest piece of information that you would have, and bits really stand for binary digits. It's either 0 or 1. So when you have the signal, 1 really represents the reach of the volts, which is 5 volts. compared to 0, that would be actually close to 0. So in digital, when they designed this, what would happen is that you would have the representation of all your data converted at the machine level as 0 and 1s. Okay, so now we will be working with binary numbers. So here it gives you a little bit more explanation. So what you have is, when we take our decimal number, in the case where, let's say, if you wanted to calculate a 5 plus a 2, we wanted to make sure that it's a 7, right? The computer actually takes that and convert it to 0 and 1s. Okay, so there are two methods in approaching this. You can, when you do binary to decimal and decimal to binary, you can use addition subtraction method, or you can use division method. So what I will do is, next I'm going to walk you through the assignment. So for your assignment, the first question asks you to convert 149, which is in decimal, to a binary. Okay, so when we look at this scale, 2 to the 0 power, so this one right here really is 2 to the 0 power. And this 2 right here is 2 times 2 to the first, right? And as we move to the left, we just simply multiply it by 2, and by 2 again, it's 2 to the power of n to represent the binary, right, in the scale. So we have 1, 2, 3, 4, 5, 6, 7, 8, right? So we would start with the least significant bit, which is the right, which is equal to 1. And then 1 times 2, that's going to give you 2. 2 times 2, that's going to give you 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2, and so forth. So you get the point, right? Now, this scale is always going to be the same. So the decimal equivalence, right, is going to be 2 times. Okay, 2
For
to
the first one on your right, you know how you have 1 is equal to 2 to the power of 0? Is it supposed to be 1 times 2 to the power of 0?
yeah. Yeah. So 1 is 2 to the power of 0. Same.
Oh, they are the same thing?
Yeah. So 2 to the power of 0 is 1. Anything to the power of 0 is 1. You can have a million to the power of 0. It's still 1.
Oh, okay.
Yeah. Good question. So, all right. So when I use the subtraction method, I would look at the scale. Okay. And I would say, what is the largest number I can subtract from on this scale? I cannot subtract 256. That's too high, right? What's less than 149? 128, right? So let's think about, my analogy for this is, let's say you have $149 in your pocket, right? And you are represented with different things to buy. So like, let's say something that costs $256, something that costs $128, something that costs $64. So you can't afford this. So what you're going to do is you're going to go down to the next one that's affordable. You're going to buy that, right? So in the subtraction method, you would start with the scale and it's multiple of 2, starting from the right as 1. And then you're going to go left by multiplying 2. Then you are going to find a value that you can subtract the decimal that you were trying to convert from without going into the negative. Okay. So I would start with 149 and I would subtract 128. Okay. If I subtract it, that means that that bit is on 5 volts. Okay. So that would give me how much? So we have 1, 2, so 21 that's left, right? So I have 21 that's left. I still have to subtract. I have to subtract until I can't anymore, until it gets to 0. Okay. So if I subtract this, I put a 1 on top. That means that that bit is on. Okay. Now 21, what's the next number I can subtract from? Not 64, so 0 there. Not 32, that's too high, 0 there. So the next number I can subtract from is 16. Okay, so if I subtract it, put a 1 on top. So 21 minus 16 leave us with 5, right? I still have to go more. So 5, I cannot subtract 8. That's too high. I can subtract 4, however, so 5 minus 4 equals to 1. And since I subtract the 4, I would put 1. I still have 1 left, right? Here's a 2 that's higher than 1, so 0. And then for the 1, 1 subtract 1 is 0. So this is our binary value for 149 in decimal. So that means that our answer, let me put 0 there. So our answer is 149 for the base 10, right, is going to be 1 0 0 1 0 1 0 1. And the odd number, you would always have this last bit on. If it's even, that will be off. Okay, so now this is a base 2. Normally, you don't see people put base 2 because when we see 0 and 1s, we automatically know that it's a binary, but the proper way is to put the base value to represent what number system that is. Okay, so this is a subtraction method. Any question with this?
Professor,
Yes.
if you put a 0 in front of the 1, would that change the value or
No.
it does not? Okay.
No. Now, when we get to 2 complement on Thursday, you know, the way that the computer represent negative number is it fills out the 1 for the rest of the word size, right? Or the size of, you know, that length, right? So in some system, a word size is 32-bit, the more modern system. In the older system like this one, it's only 16-bit. So when you see a value, for example, like this, it means that it's negative because if our value only comes up to here, it uses the rest of the bits in the front to show that it's a complement. That means it's a negative or a sign, right? In C++, you have unsigned and signed, and you can put in the type like int and this to represent positive and negative. Well, how does the computer translate that, right? It's going to say, oh, it just turns on all the bits in the front and it's going to hold that to represent a negative sign, okay? Or we call that sign. And if you put the 0, it doesn't change the value to answer your question. All that is just saying that, you know, the rest is going to be 0. Okay, so now if you put this into a calculator, okay, there's a programmer mode. So you go to the top and change it to programmer mode, okay? So if I put in decimal and I put 149 like this, right? I see that this is the binary. And notice that it chunks it into 4 bits. This is what we call a nibble, is 4 bits, right? So in a byte, what it is there's 4 bits, and the least significant is on the right. Yeah, so it just assumes that there's all 0 in the front. For, you know, if you're looking at 16-bit, the front is all 0. Now, if I put in a binary value, that's going to be 0, 1, 1, 1, 1. See how it just eliminates that 0 because it's just nothing, right? It's off. So it doesn't care about any 0 in the front when it registers that. Okay. Any question? Okay. All right. So let's look at the next one. Let me take out this so it doesn't confuse you. Let's try the next one, B, 307. Okay. So 307, right? We're going to start with subtracting 256. So if you subtract it, you put a 1 on top. And then whatever's left, you keep subtracting until you get the 0. Anytime that you subtract the number on that scale, you put a 1 on top. And if you don't, because it's too high, put a 0 and you will get your binary. This is the easiest method that I found. You can use the division method, you know, in the notes, it also shows that too. Okay. So try B. I will start for you. We would start with 256 and then get the output from that and then keep subtracting. So if you subtract it, you put a 1 on top. And after 256 is 512, it's too high. So you cannot go above that with 307. Okay. And then you keep subtracting until you get to the 0.
I got 51 for 307 minus 256.
Okay. And then what would be the next number you subtract?
32?
Not 128. So you zero that out, right? And then so you would take 51 minus 32. You put a 1 there, right? Okay, so that should give you what, 19?
Yeah.
And then you have to subtract 16 because that's next. So 19. I'm just writing down the step for you so you can see that gives you 3. So it's going to skip 8, it's going to skip 4, and then it's going to do 1 and 1 at the end. Since it's an odd number, you know that this last one is on. Okay, very easy, right? So for the final and quiz, you are expected to know how to do this, okay? And you will not have a program or calculator because I use Lockdown Browser, but you will have a scientific calculator that you can use just in case. Okay. You can work on 48, and so that should be really easy. Start with 32 and then go back.
Hey, Professor.
Yes.
For this class activity, do you want us to be doing it with you?
You don't have to, but you will need to turn it in.
Oh,
I
okay.
just do it to show you so that way you're not lost. Okay.
I opened the Word doc that you had for the homework.
Mhm.
Am I supposed to make my own copy and then?
No, you can fill it in and then save it and then submit it. It's there for you to put it in. You don't have to use the table. However, I've made the table because throughout my years of teaching, I found that the student visualize it better using a table instead of making their own scale. Okay. But you can type out the work and then put the answer. Okay. Jason put something in the chat in case if you can't download it. Now, if you don't have Microsoft Word installed on your computer, you can use the Office 365 login, right? And then I'll put in a page for you to show where you can download that. Okay. So now let's go in reverse because I do only have about 30 minutes left with you and I wanted to cover as much as I can so you don't get confused when you go through the assignments. Okay, so when we went from decimal to binary, we subtract. Now, if we go the other way, when we go from binary to decimal, we simply add. Okay, and this is the easier technique, but so this one, this is the given value in the example. You have 0, 1, 1, 0, 1, 1, 0. So you would start with filling out the bits starting from the right, go left. And then anytime that you have a 1 on top, you just add the value for the scale, the decimal equivalent scale. Okay, so all of the ones that have the 1 on the top, you add them. So basically 32 plus 16 plus 4 plus 2, right? This is 20, 52, 54. Okay, so your decimal equivalence of this binary is 54. And as it is an even number, you notice again, the least significant bit is not on. Okay, we can tell odd or even from that. Okay, let's try one together for D. Okay, so I'm given for D this binary, and then I simply put that into my table to make it easy. Okay, 1, 1, 1, 1, and 0, and 1. Want to make sure I have all the ones. And then once I do that, I just add up the decimal equivalents where I have the 1 on top, because those are the bits that are on, right? And so you just take 128 plus 32 plus 16 plus 8 plus 4 plus 1, and you would have your decimal output. So that means that it need, you know, when it when it shows you, right, a certain value, then it has to go through the encoding process. So it ultimately everything is in binary, right? And if you're using like different type of encoding, it's need to convert that and show you what you need to see, right? If it's ASCII, then it needs to convert it from an ASCII value, like an A is 65, and it takes that value and it converts it and it shows you it's an A. Okay. Okay. Any question regarding converting from binary to decimal using addition? Okay, you can try. Oh, I see something in the chat. All right, good. If you don't want to ask now, if you have questions, you're welcome to see me during office hours and we can go through the steps. So there's some practice for you to do to convert it to decimal back. Let's talk about adding binary, okay? Because when you simulate, sometimes you have to see, oh, is that really a sum in binary, right? Like if we're taking 24 plus 14, what is that really? How does it look like in binary? So the rule for adding is that when you take a 0, add a 0, you get a 0. When you have off plus off is off. When you have 1 plus 0, you would have a 1. 0 plus 1 is also a 1, but a 1 plus a 1 is a 0 with a carry. So it pushes that bit to the left, to the next place, okay? It's kind of like if you do 5 plus 9, right? It's 14, so you have a 4, and then you bring the 1 to the left place, the 10th place, okay? So when we add binary, it's like that. We would carry the bit to the bit to the left side of it, and then it would then be added again if there's additional addition needs to occur. Okay, so that means it's a 0 with a carry 1. So when you look at this example, we have 0 plus 1 that gives you a 1. 0 plus 1 also gives you a 1. A 1 with a 1 is a 0 with a carry. Okay, so here comes the tricky part. Okay, when you deal with the carry, handle 2 numbers at a time. Okay, so what happens is I would start with the carry and the top number here, and I would do a 1 with the 0 is a 1. Okay. And then a 1 with the 0 is a 1. Okay. There's also videos that I included in the link where it also break it down. So when you have a carry, remember, just like how you do addition with decimal number, you take that carry and you add it to the number at the top and then add it again. So we do the same thing here. We take the carry, add it to the 0, you get a 1, and a 1. That 1 is going to be added with the second number, which is another 1. Okay. And then a 0 plus a 0. So the carry is finished out there. So 0 and the rest are just 0. Okay. So basically it brings it to the left bit. It carries over 1. Okay. So in some case, you might have multiple times that it's going to carry. Okay. Like when you do the addition for H, you would have 1 plus 0 is going to be a 1. 0 plus 1 is going to be a 1. A 1 plus a 1 is going to be a 0 with the carry. And then that carry plus a 1 is another 0 with the carry. And then a 0 plus a 0 is a 0. Okay. Everyone got that? Any question? This is where sometimes it gets a little confusing. And
Wait, so you said if you add 2 1s, it's a 0 and then you carry it, right?
Mm-hmm.
So if there's 3 1s now that you carried it.
Yeah, so it has to be, so you still add it, and as it carries, it's going to bring it to the left side, and then you handle those carry first, and then the next number, and then so forth, 2 at a time.
Do you mind like showing how to do H?
Sure. So a 1 plus a 1 is a 0 with, yeah, to carry to the left. That is correct. Let me see if I can, hold on, let me stop share real quick. And then let me see if I can use the board. I don't know if I enable it for this class. Okay, hold on 1 second. I thought I did. Okay. All right. I'm on this laptop, which it doesn't have a stylus. So I'm just going to try to use my finger or the pen. Okay. So let's try. I'm going to do another one that's going to be easier. So I hope you grab it and then grasp it, and then we're going to do H. Okay. So
okay.
let's do like a 14. Right? And then we're going to plus a 9. Okay. So let's convert 14. So 1, 2, sorry. 4, 8. So that means that this is on, this is on, this is on, and that's off, right? And then for the 9, we're going to do 1, 0, 0, and actually I want to do something higher, sorry. So let me do another number. Let's do another 14. Okay, that makes it easy. Okay, so we have 1. Oh no, I don't want that. Sorry. 1, 1, 1, 0 plus, sorry, chicken scratch right now. 1, 1, 1, 1. Okay, we know that when we add this, it's supposed to give us what, 28, right? Okay, so let's check. 0 plus 0 is 0. Okay, a 1 plus a 1 is a 0 with the carry, right? Now, what you need to do is you need to handle it with these two first. Okay, so a 1 plus a 1 is a 0 with a carry, right? All right.
Yeah.
A 0 plus a 1 is a 1. Okay, now we're going to do these two, right? So let's swap pen. So now we're going to handle these guys first. So a 1 plus a 1 is a 0, again with the carry. A 0 plus a 1 is a 1. And then think of this as arbitrary 0, right? And then 0 here. So the 1 just dropped down. Okay.
I see what you're saying now.
Okay. Does that help?
Yeah.
Okay. So you guys try H. That should be really easy. Okay. And if you convert this back, it should match. If you're off, then something happens, you miss a carry or something happens.
Oh, so the numbers to the side of H, the 4 and the 7, those are just the actual numbers that we're adding, right? That you're saying.
1 second. Let me bring back my document. I was in board, so. Oh, so what do you mean by 4 and the 7? Oh,
It's
yes.
the example right above it.
Yeah, so this is just the example. So what it's showing here is 0, 1, 2, 3. These are the bits position, right? Starting from the least significant going left. So you would start with the first bit, right? So a 1 plus a 0 is a 1. A 0 plus a 1 is a 1. A 1 plus a 0 is a 0 with the carry. A 1 from the carry plus a 1 is a 0. And then we add the 0 again, we get a 0. Okay. And then you keep going. You want me to show you? How much time do I have? Okay. I think I should have time to cover the hex. If not, we'll pick up. So let's do this. Sorry, let me stop share real quick. Someone have a question in the chat? Yes, you just keep on going until there's no more to subtract or add. Or I'm sorry, add. We're doing add right now. Okay. All right, let's share screen. Let's do this. So let's clear it. Clear. Okay. So we are going to do H. Let's see. 1, 0. I'm going to copy this text real quick. So all right. Okay. So we have 1, 0, 1, 1, 0, 1. As you can tell, I'm not a graphic designer because I'm horrible on the mouse. Okay, so 1, 0, 1, 0, 1, 1, 0, 1, right? So that's, and then we have 0, 1, 1, 0. Am I 0. Okay, I think that's right. Okay, so we're gonna add this. So starting with the right, we're gonna do 1 and 0. We're gonna get a 1. And then nothing carries. 0 plus 1 is a 1. 1 plus a 1 is a 0 with a carry. Okay, let's switch pen. So we're going to handle this part first. Okay, so 1 plus a 1 is a 0 with the carry. A 0 plus a 0 is a 0. Then again, we're going to handle the top part. A 1 plus a 0 is a 1. A 1 plus a 1 is a 0 with a carry. A 1 plus a 1 is a 0 with a carry. A 0 plus a 1 is a 1. A 1 plus a 0 is a 1. A 1 plus a 1 is a 0 with a carry. A 1 plus a 1 is a 0 with the carry. A 0 plus a 1 is a 1. All of this drops the 1 down. Okay. Sorry about my chicken scratch. I try to draw on screen, but is that okay? And of course, you can use your calculator to check. So the output here is just with the carry and the top number, and then you take that and you add it again to this line right here. And then if it carries, bring it again. And so only handle 2 numbers at a time, 2 level at a time. Okay, any question? All right. So as I have about 14 minutes.
I think I can hear your dogs.
Yes. Oh, yeah. Mr. Lane, right? I remember you. Okay. Yeah. That's my female dog. She's drinking water. All right. So let's talk about the next part, which is hexadecimal. Okay. So in your notes, it also shows you how you can do division method for the conversion. And then in the hexadecimal, when we look at hexadecimal, hexadecimal is 0 through 9 as numbers. So if you have a 0 in decimal, it's a 0 in hex. If you have a 6 in decimal, it's a 6 in hex. But if you have a 10 in decimal, it becomes an A in hexadecimal, right? And then it becomes a B for 11. For if you have 11 in decimal, it's a B, and so forth. So hexadecimal system is a base 16 from 0 to 16 in decimal equivalence, right? Where 0 through 9 are numbers and A through F. So when we converted hexadecimal to binary, you simply take the hexadecimal and then you treat each of the hexadecimal as 4 bits as a nibble. So when we're looking at hexadecimal value for E, the 4, we just need to convert it because a 4 in hexadecimal is the same as 4 in decimal. So we just need to convert it to binary. So 1, 2, 4. So you know that bit is on, right? So the 4, the third bit, which is a 4, that's on, and then the 8 is off. Okay. So for the 4, the binary representation is 0, 1, 0, 0. For E is, so you have A is 10, 11 is B, 12 is
Oh,
C.
Professor, the
Yes.
screen isn't on.
Oh, I'm sorry. So if A is 10, 11 is B, C is 12, D is 13, and E is 14. So we know that we have to have 14 equivalents in decimal. So when you convert 14, you would get 1110. So together you combine the 4 bits for 4E in hexadecimal. Here's the 4, right? And then the E are these right here. Okay. All right, let's try this one. Okay. So we have 4B, 1C. So let's start with the C. So the C is what? A is 10, B is 11, C is 12. Okay, C. So the
Wait,
decimal.
you said, can you go over the A, B, C, D?
Yeah,
I didn't
so
catch it.
so in decimal, if it's 0 through 9, right? Your hex is also going to be 0 through 9. It's the same, right? But when you have a 10 in decimal, right, that's going to be an A in hex. Okay. 11 in decimal, that's going to be B in hex. 12 in decimal, that's going to be C in hex. 13 is D. 14 is E. And 15 is F. Okay.
Got it.
So we're going to start with the C because it's the most right? You can start with 4, right? But I wanted to show you the C. So C is equal to 12 in decimal. So we, just like what we did before, we can use the subtraction method and find out our 0 and 1s in binary. Yeah, so 10 is always going to be A, not 0. So 10 is always going to be A. 0 is 0. Okay. Yeah, A through F is 0 to 15 because hexadecimal has 16 numbers, 0 through F, right? 0 through 9 are numbers and A through F are letters, right? So when you're working with, like, you know, programming HTML with the color wheel, the color code, right? You would see that it has numbers and letters. So this, the 0 through 9, and it goes to F, and that's your hex. So starting with C, 4 bits. So that's going to be, you're going to have from the right, we're going to have 1, 2, 4, 8. So the 4 and the 8 is on for 12. 1, 1, 0, 0. Okay, because 1 is off, right? So we go down, we subtract, right? What's the largest number it can subtract? We can subtract 12 with 8, right? So 12 minus 8 is 1. And then after that, we have 4 left, and we minus the 4, that's 1, and we have nothing left because the 2 and the 1, there's nothing left to subtract, so that's 0. Okay. Then we would go to the next one. So that will be C. What's the next letter? That's going to be 1, right? That's easy, very easy. So your 1 is going to be, let me bring this down. So your 1 in hexadecimal, that's going to be 1 in decimal, which is going to be 0, 0, 0, 1, because 1 is on, right? And then what's the next one? B, right? B is 11. So 11 is B, and that's going to be 8. Oops. 4 is off, 2 is on, and the last one, the 1 is on. Okay. So the highest number you can subtract from is 8. That gives us 3. We can subtract 2 and 1. That gives us the last 2 ones there. And then the next one is 4. So 4 4 is 4 in decimal. So that's going to be what? 8 is off, 4 is on, 2 is off, 1 is off. So when we combine this together, our answer should be starting with the 4, that's the most significant, 0, 1, 0, 0, and then 1, 0, 1, 1, and then 0, 0, 0, 1, and then 1, 1, 0, 0. That's your answer.
Hey, Professor,
Yes.
would you say a shortcut to this is that when the number is an odd number, it's going to end in 1, and when it's even, it's going to end in 0?
Yes.
Okay.
Yeah, because the least significant bit, the rightmost bit in binary, right? That always going to be 1. So yes, if it's an odd, it's going to turn that 1 bit on. Okay. And what it does is it chunks it. So when you go from hexadecimal to binary, take each of the digit in hexadecimal and treat it as 4 bits, right? In binary, and then just convert it. Okay. Right? Any question? Okay, I have about 5 minutes left. If I don't finish this, I will touch on it in the next one. But workout number 2 under the hexadecimal conversion. So just now this one changes to decimal. So a lot of the students, what they do, and I think it's easy to do, it's a good way to do without having to use your calculator, is to first take the hexadecimal, convert it to binary, like what we just did, break it down into 4 bits, and then take the binary that you find, convert it to decimal. Okay, 2 steps. Now, or you can use the division method that's shown here. And what you simply do is, if when you're going from decimal to hexadecimal, you can divide, and you can go in reverse and multiplying using the 16 to the power of n. Okay. So let's look at the division method going from hexadecimal to decimal, and then I will show you how to do the multiplication maybe next time. Okay. So you would take the decimal number and you would divide by 16 because it's a 16 base. Okay. So as you divide, you're going to do long division. So that's why division method, sometimes people don't prefer it because you have to do long division and you got to use the quotient to keep dividing. But the remainder is important because the remainder represents a value. Okay, that's of importance. Okay, so if I take this 61,000, I divide it by 16, I would have the quotient, I would have 3840, right? It would have a remainder of 13. And this 13 represent D in hexadecimal. Remember A, B, C, D, right? D. I'm not done. I would take again 3840. I divide it by 16 again. Next step. Okay. That would be 240 as quotient with 0 remainder. You have to put down the 0 as remainder because 0 is 0. Okay. Then we would take 240 divided again. We would have a quotient of 15. So 240 divided by 16, we would have 15 with 0 remainder. It's also a 0 there. And since 15 now is smaller than 16, we can still divide it. That will be the last step. When you get the quotient that's smaller than the value that you were dividing with, which is 16, that will be your last step. Take 15 divided by 16, you will get 0 with a 15 remainder, because basically when you convert it, you're doing what? A mod 16, right? So you would take that divided by 15 divided by 16, you would get 0 with 15 remainder, and 15 is equivalent to F. So what, because remember, we're going from decimal to hexadecimal. So the way you write it, the output of this is gonna be X, because it's a hex, right? F00D, going from bottom up, left to right. Okay.
So that 0x means hex?
Yes. In some of the applications, like if you used Unity, and if I recall correctly, there's some system that would use 0x for, you know, addresses, and then in Lc3 we learned we just use an X. But yeah, that would just represent that it's a hexadecimal. Or you can put the base 16 to show that it's a hexadecimal. Okay, but hex is used for addresses like, you know, IP version 6, MAC addresses, like for your physical addresses for your network, you know, card, either wireless or Ethernet. And then it also used for memory addresses. So hex is used for that. And that's why we need to know what it looks like and how to convert it.
And when we're using hex on, do we always use 16?
It is hexadecimal is base 16. Yes.
Oh, okay. No
So
problem.
when you convert it to hex, you use 16. Yes. If you convert to binary, you divide it by 2. All right. So I'm over my time, but what I will do is I will touch on this, two's complement, and, you know, the other stuff for the lab. We're not going to do a regular lab this week. We're going to cover the rest of the concepts. So I want to make sure that you get to the point where you understand how to do this. So I will revisit this. And then what I'll do is I will possibly push out the assignment due date to like the end of the week or something like that. But you're welcome to try it out on your own and go through the notes. It should be very easy to figure out as you follow the example, okay? So when it says unsigned, that's positive. When it says signed, it's negative. If you can please type your name into the chat, just to make sure, because sometimes if you're using a different name to log in, I might not see you. So, and I pulled the attendance Zoom roster from Zoom, so, but just in case. Okay. So we will finish this out next time, and then we'll finish the lab portion of it. Please go through the notes, and thank you for a good first day. I will see you again next time. Bye, everybody. Have a good night.
Bye, Professor.
Bye.
Hey,
Yes.
so I don't think you've heard my voice since like before the pandemic began and you were still in class.
I remember you said you were sick, and I wasn't sure what happened, but you
No,
turned in your project.
I wasn't sick,
Oh, okay.
but I remember like my microphone was broken when we started Zoom meetings. So like, yeah, I don't think you've heard my voice since before the pandemic.
I know. But I remember your voice though. So like when you said that, when you said I heard your dog, I was like, oh, I know that's Ryan.
Yeah, I remember we were in class for like a few weeks early in the semester, and then we had to go to Zoom.
Yeah, and it's unfortunate, but you know, it happens, and maybe down the line we'll be back. But I remember your voice. Good to hear from you again, though.
All right, see ya.
Take care. Bye. Any question before I sign off? No question? Okay, have a good night, Jose and Tanner.